And this, let us take an example. This is a GATE 2018 instrumentation question. So if you can read this question, in a given circuit, the superposition theorem is applied when V2 is set to 0. When V2 is set to 0, the current I2 is minus 6 ampere. When V1 is set to 0, the current I1 is plus 61 ampere. Then what is current I3 in ampere when both sources are applied? When both sources are simultaneously applied. Understand? So if you look at this question, if I only take the first condition, what is the first condition? Condition 1 is setting V2 is being set to 0, then what is telling? The current I2 is minus 6 ampere. And what we need to compute? We need to compute I3. Okay. So if I nullify the voltage source V2, how you have to nullify? You have to short circuit it. If you short circuit, the circuit will become what? The circuit will become, I'm directly using the resistor symbol. So the remaining 2 ohm will be parallel. Now why? Because this voltage source is short circuited here. It is short circuited. So what are the elements now present? It is 3 ohm, it is 2 ohm, and it is 6 ohm. This is the circuit after nullifying the source V2. Now what data he gave? The currents that are flowing, the current I2 is minus 6 ampere. Where is I2? I2 is flowing through the 2 ohm resistor. It is minus 6 ampere. And I3 is flowing through the 6 ohm resistor. This we need to compute. This we need to compute. Very simple. Very simple. Here what is the voltage across this 2 ohm resistor? It is 2 ohm multiplied by minus 6 ampere. The voltage across the 2 ohm resistor will be minus 12 volt. Minus 12 volt. Since the 6 ohm and 2 ohm are in parallel, the same minus 12 volt will be across the 6 ohm resistor. So here also the voltage is minus 12 volt. Here the voltage is 0. So how much current will be? What will be now my current I3? The current I3 will become minus 12 volt divided by 6 ohm. What will be this value? It will be minus 2 ampere. Minus 2 ampere. So because of this, because of the source V1, the current I3 is minus 2 ampere. Understand? Now if we take the second condition, what is the second condition? Condition 2. Now he's setting which voltage to 0? In second condition, V1 is set to 0. I1 is 6 ampere. V1 is set to 0 and is telling that I1 is 6 ampere and we need to compute I3. We need to compute I3. So if you set V1 to 0, the circuit will become what? V1 is 0, 3, 6, 2. Okay. So this is 3 ohm, this is 6 ohm, and this is 2 ohm, and this is V1. Sorry, V2. Okay. Now the values are 3, 6, and 2 ohms. I hope I've copied correctly. Yeah, 3, 6, 2, and this I1 is 6 ampere and we need to compute I3. Okay. Now if 6 ampere flows this one, the voltage drop across the 3 ohm resistor will be current entering terminal is marked positive, current leaving terminal is negative. So the total voltage drop across this is 6 into 3, 18 volt. 18 volt. Understand? Now if you can observe, the 6 ohm and 3 ohm are in parallel. The 6 ohm resistor and 3 ohm resistor are in parallel. So the same 18 voltage will be across the 6 ohm resistor. So here also the potential of this point is 18 volt. The potential of all this point, this is a common point where the potential is 0. Now if you compute the current through the 6 ohm resistor, this I3 will become how much? 18 volts divided by 6 ohm, that is 3 ampere. That is 3 ampere. So I3, because of the V1 source is minus 2 ampere, I3 because of V2 source is 3 ampere. So when both V1 and V2 are acting simultaneously, what will happen? Your net I3 will be algebraic sum of the two responses, that is minus 2 plus 3 ampere, which will be 1 ampere. Understand? Algebraic word because you have to keep the polarities of those currents or voltages intact. Okay, you have to consider both polarity and magnitude. That is the algebraic. I hope you have understood this question. If you have understood, I'll move forward. Gentlemen, any doubt?
No, sir.